Code is communication. Mr. Larsen, I presume?
Yes, and I feel thankful that I'm here to welcome you, Mr. Donald.
We're two seasoned software engineers, and in this podcast we want to talk about what makes code high quality. Communicating the intent to the other team members.
Exactly, and you could also broaden this to a broader scope as well, other stakeholders. But to start off this series, we would want to discuss why proper, as in thought-through communication, should be an important or even integral part of software engineers' daily job.
Actually, I think it should be the most important part. Even if you write code only for yourself, you will want to read that next week and you want to be able to understand it. So you will need to communicate your intent in the code.
Yeah, that's very much correct. Yes, we agree on that part. So should we start out with a few examples where communication has failed?
Pretty much everywhere, hasn't it? I mean, every one of us has written code that he didn't understand a week later himself. We've all been there. Do you have an example?
The common case is when you're working on one task and then you have to quickly shift over to another one and then you get back to the original task and then you're a bit lost what you were trying to achieve or some assumptions that are not clear from your own code.
Yeah, that's true when you're coding on your own. And there's also that you want to communicate with your team members as well. So you have to, even if it's not you coming back to it, you have to go to a code review and the team members have to be able to understand what you're trying to do with this code. And they don't only have to understand how you're doing it, but more like what you're trying to achieve.
Yeah. And I think the skill part of this is really not over-communicating while still maintaining the goal of having it as clear as possible.
That's true.
If you know what I mean. So the different side to this is we've all seen that kind of code as well, where everything is commented on. A lot of superfluous comments all over the place.
Yeah, I'm not a big fan of many comments anyway.
And I also believe this is a common paradigm in clean code as well, that the code should more or less be self-explanatory.
Yeah, it should be self-explanatory. And the thing is, what you've written in code is executable. But what you've written in comments is never checked that it's correct.
Yeah.
That's why I prefer to communicate in the code itself and not in comments. Sometimes you need to explain bigger concepts, but I don't think that comments are a good place for that. Because the concepts you want to have an overview document that spans over like 10 or 20 classes to explain a concept. And there's no good place in the code where you could put that. So you should have in the repository so that it's versioned with the code, but not in the code itself. So like in additional document, Markdown, LaTeX, whatever you prefer.
I guess this is a topic on its own, but what's your view on communicating through tests?
I love that.
Yeah.
There's different levels of communicating through tests. So one is actually the specification itself. So you can write the specification as tests.
Yes. So you're bordering on the topic of test-driven development.
Yes. And when you have the specification written as tests, you will not have fine-grained enough tests because there's so much that you don't have in the specification, which you have to still have to test the code itself. I actually prefer to use different test frameworks. So for the specification, I like to use something like Gherkin tests because they are readable for the
non-developer.
Exactly, for the business side. And it also sets a language. So you have the language of the business people on top.
Exactly. That's a very good point, because I think a lot of problems arise when you're not using the same language, when you're discussing different topics, even though you're still thinking you're on the same problem, but you have a totally different definition of it.
Yeah.
I mean, this is also somewhat like stakeholder management, but that is a very important part of communication.
Mm-hmm. Yeah, it's also kind of another way of communicating with code, because Gherkin tests translate to code.
Very true, yes.
So you communicate in the business language, and then you can start from there with your implementation and break down the problem with decreasing levels of abstraction. I think that's basically the core of communicating through tests. Also, good unit tests, the more fine-grained ones, also can tell the reader how your class is meant to be used.
Yes.
So I think that's also very useful. So I like communicating with tests as well.
We can all agree on that. But in the end, in reality, you have the problem of people not wanting to spend too much time on implementing tests, etc. That's my experience, at least, that quite a few developers see that as a non-important task that they could leave till the end. But that's the wrong way to look at it, in my view.
Yeah, I've seen those colleagues as well, but more often managers who were trying to save time by not having tests. I think that's another aspect of how we as developers have to communicate. We have to tell them, no, that's an integral part of what we are doing as developers.
And it's truly a skill in itself, designing tests, because if you overdo it, you end up with a set of tests that simply takes too much time or too much resources to run. And then developers will just skip them, and then you are left with no benefits of testing.
Yes.
I mean, I think it's very common in Maven. You can just disable tests and then run it and save yourself a lot of time. So you have to be careful in designing the tests, of course.
Actually, that's also important. What I was just trying to say, the most fun project that I've been in ever, we had a test coverage of 98%. That was a C++ project, and the 2% came from a very specific thing in C++. When an object is destructed, when the destructor is called, the compiler inserts code to check that it's not a null pointer. And we didn't have tests for that. That's why we didn't have 100% code coverage. We had 90% branch coverage, actually. So not only the code itself was executed, but every branch of the code was executed in our tests. And that gave us so much safety that we were able to do big refactorings by just making sure that the tests still run.
I mean, this is maybe one of the most important results of well-designed tests or comprehensive tests, is that you can do refactoring without much hassle or risk. You reduce the risk of refactoring.
Do you have an idea of how tests are well designed? How should they look?
Yeah, I would say, I mean, to start, maybe I'm not answering your question now, but my idea here is that there's also the risk of, when you have this single-minded goal of having very high code coverage, you tend to, in the end, manufacture tests that are just bogus tests that don't really test anything. Right? So I'm just saying now that you can't just say, okay, let's have code coverage of 100%, and then you're set.
Yes, that's true, because you actually have to have tests that don't just run the code, but run the code on the edge cases.
Yeah. And then I think there are several different layers to this, but one important distinction is between unit tests and system tests.
Actually, I've been teaching that like 15 years ago. Usually it's 3 layers, unit tests, integration tests, and system tests. And the idea is that unit tests really test the code. They can be white box tests. So you know the code, you know what you want to test, etc. The integration test the interfaces between the units. You spin up like 2 units, mock everything else, but the communication between those 2 units, that's what the integration tests test.
Yeah.
And the system tests spin up the whole system and run on top of that. And what we've been talking about before, the specification is usually on the system test level.
Yeah, that's correct. That's a very good summary of how you should approach testing.
Hmm?
And ideally, you should have all three levels in your project.
Yeah. But let's start with unit tests. How does a good unit test look in your opinion? I mean, if you just look at code, how do you want to see a unit test?
In my belief, it should be as isolated as possible.
Mm-hmm.
So you mock everything you don't want to test. So you really need to narrow it down to what exactly are you testing.
That also includes the design. So it will reflect on the design to make it testable, to make it possible to drill down to what you're actually testing.
Yeah, and in a way, depending on how you view it, this could be just a result of test-driven development. When you start out with the tests,
mm-hmm.
then in a way you could say that you get this for free then you get good unit tests for free. But on the other, free is a strong word because you still have to spend a lot of time designing it properly.
Well, you can still write terrible unit tests, I think.
That's true. That's true.
There's one thing that I'm always looking for when I look at tests. I want to see one call to the function on the test, exactly one, and no loops.
Yeah.
In any unit test. It's not that loops in general are terrible, but in a unit test, you tend to use loops to test multiple things, and that's a bad thing. You write multiple tests, so that don't repeat yourself doesn't apply to unit tests, I think.
Exactly, and with loops, you also run into the risk of having not exact input and output state that you were aiming for.
Yeah. And even some test suites that I've seen that in some Python test suites allow you to reuse the same function with different parameters. I think that's a bad idea because you still have the same name of the failing test. So the name of the test that is failing should tell you what is wrong.
Yeah, I agree there. I mean, there we also have the naming conventions, and I think they're fairly standard.
Mm-hmm.
One of the easiest one is to just include it in the name should respond with exception or should throw exception,
mm-hmm.
for instance.
Mm-hmm.
So you have it in the naming, and then in the actual test itself, I think there are various ways to do it, but one very simple one is to have given. So the assumptions or input, and mm-hmm. then you have when, blah, 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 so mm-hmm. certain conditions, and then. So that should be the expected outcome then, or test for the expected outcome.
Yeah. But the when part, I think, should be just one call.
Ideally, yes, I agree.
Yeah. Actually, I don't think ideally. I think every unit test should only call the function once. Exactly once.
You're right. I mean, now we're deep into a testing discussion, but that's also a very important part of mm-hmm. communication. Maybe one of the most important ones.
When you do the setup part, I think people who are concerned about having a repetitive code in tests are mostly thinking about the setup part. There, I think actually fixtures are a very good way to solve that. Though sometimes they can become too complicated. So there's a fine line between having useful fixtures and having fixtures who are so complicated that you want to test them themselves.
Yes. One part we haven't really mentioned about tests is that refactoring shouldn't lead to too much changes in the actual tests themselves. Then there's something wrong with the design.
Yes, but sometimes you do the refactoring to clean up something that is wrong in the design. Then you will have significant changes in the tests. But that's where those levels of tests come in. So the system tests should only change when the requirements change, I think.
Yeah.
And the integration tests should only change when the architecture changes.
Yeah.
Maybe you want to do some detailed things like we have extended this kind of message, and that's not exactly an architecture change. But in general, if you do big changes in the integration tests, it's architecture change. And unit test changes, they happen more often. And that's exactly why I think they should be as simple as possible so that you can be sure that the test itself does what it says right up front with its name and with the test code.
Yes. I mean, some even argue that you should have the flow outlined in the test name. So when this happened, then blah, blah, blah. But that's a bit of a matter of taste as well, how exactly.
Yeah, and it's also like, how long do we want to have the test names? They should be clear.
Yeah.
I like if the test names point me to the place in the code where something is wrong. So usually, they have to start with test underscore or something like that, so the test framework picks them up. But then I like to have the class name, function name, or maybe just the function name if we're working with free functions, and then a description of which situation you're trying to test. Like you often have that, like test my wonderful class sunshine test. That is, everything should run smoothly here. Test my wonderful class exception on too big input number or stuff like that. So I like to have that. You always have a pointer to where in the code something is going wrong when this test fails.
Yes. I just wanted to highlight that with tools today, it's very easy to set up testing in the pipeline as well, so you don't risk deploying faulty code, which could be very helpful or even time-saving.
Yes. So at least for the unit tests, I like to have them run in a loop while I'm working on the code. So as soon as I change it, as soon as I save a file, it will pick it up, will run the tests, and will go to red if I broken something.
Yeah, that's very convenient, yes.
Yeah. So usually I write a shell script, but that's me because I'm rarely using IDEs. But IDEs have tools like that as well.
What I was more talking about was when you have these CI/CD pipelines where you can make sure that you test with containers, you can actually test in the exact same environment as what you want to deploy to.
But you can also run containers locally. You can have at least the unit tests always running. But I know some people don't do that. So for those people, it's a good idea to enforce the tests in the CI/CD pipeline and disallow merging when tests fail and stuff like that. Yeah, I agree. Now, going away from tests, let's look at, for example, how would you think a good function should look like? Is there some kind of idea?
Yeah, I would want to say that there's as a result of everyone reading clean code and trying to stick to this, the ideas are fundamentally sound, I would say, but you can always overdo it. So you tend to end up, if you look at some people's code, you have very, very small functions.
Mm-hmm.
Too small to be clear. So in the end, you will run into the opposite of what you wanted to achieve. But as a fundamental idea, it's good to keep functions. They should solve one task, one task only. But there are, of course, in reality, you will have exceptions to this.
I have a rule of thumb in my head, which not always is perfect, but in general, I say that a function should do one thing only and on only one level of abstraction. So when we come back to that idea that the specification is in the language of the business, the first level of abstraction will be in that language. So you will have functions within that language. Those functions call other functions which are one step away from the business language towards a technical perspective.
Yes.
And then the next step. That's also something that you can overdo, of course, because then you have like functions that do nothing but call a function, just changing the name. Sometimes that's useful, but often that's a sign that you're overdoing it.
So as with most things in life, it's not black and white, but just looking at the idea, it's very good to keep it to one task and one abstraction layer.
Mm-hmm. And I think when you have the function in one abstraction layer, it's also usually a lot easier to read because you don't have to mentally flip to different abstraction layers, like calling a function on an object and then iterating over something internal in that object. That's like feels like there's a good chance that you're not on the same level of abstraction here.
And there's also, I mean, now you don't use IDEs, but in an IDE you could use, for instance, let's say the SonarQube tool suite, where you get hints when a function is too complicated or too complex.
Yeah.
And that's, I mean, it's not always right, but it's a helpful tool to keep your code in check.
But that only checks the upper bound. It doesn't check the lower bound. True. I think there has to be a balance there. But I think we still haven't talked about the most important part of the function.
Yes.
I kind of pointed to it already, but we haven't talked about it explicitly. So the name of the function should be on that abstraction layer that the function is used in.
Yes.
For example, if you have an invoice object and want to create a PDF, then you might have a function called createPDF on the invoice object. Inside that function, you get one level of abstraction lower, and that would be like fetch the values from the object, run the template engine that creates, for example, Markdown, and then run a processor that creates the PDF. All of that on that level that I'm talking about. So it should really be function calls, what I'm saying. So when you read that function, it would just read like, okay, I fetch the values, I run the template engine, and return the result. The details are on the next level. So you have these levels of abstraction, and each function reads like prose on that level of abstraction.
Yeah. No, I think it's simple but good idea to have, because this is really the fundament of communication in terms of code. I mean, that's what you end up looking at most of the time, is actually the function names.
Yes, at least on the caller side. I also think function names are one part. The other part is, of course, the other names like variables and classes. But all of them together should be chosen with a user of your class or of your function in mind.
Indeed, yeah. So, I mean, it sounds like very simple concepts, but in reality, there are grave consequences of ignoring these simple rules. You would save yourself and your team a lot of work if you adhere to these naming conventions.
Yes, and it's also remarkably hard to actually do that. That's kind of surprising.
Yeah. That also highlights the importance of having simple rules. I mean, even if people don't follow these simple rules, you should try to stay away from overly complicated ones that people don't follow in the end. I mean, there are several examples where you have really great ideas on how to do things, but they're just too time-consuming for people to follow. So then it's better to come up with a compromise in the end. So it's not obvious what kind of rules you should have in place in your team.
Yeah, but even those rules are often hard for people to follow because they're kind of stuck in the rut of what they've always been doing or what they've been taught to do, because much of the things we do wrong is what we've been taught by our teachers.
Yes, and I think it's the rare case today, at least, that you stick with one team, one project for the entirety of your career. It's rather on the other end that you jump around a bit, or that everyone jumps around a bit. And then it's even more important that you have clear and simple rules for how you should approach things, because they won't be 100% the same across teams or companies.
Yes, on the other hand, people might use that as an excuse to not communicate because, well, I'm going to be away when that hits.
Yeah, exactly. Not my problem.
It's not my department, says Werner von Braun. Now, we've discussed a lot of things today. So what are our lessons learned? One is have good tests on all levels. Have good unit tests, have good integration tests, have good system tests. Ideally, you start with them. Ideally, you do test-driven development. I know it's a discussion and not everyone likes it, but it really leads to better system design. Number 2, have simple and flexible rules that don't restrict you too much, but should be clear and easy to follow for everyone. And the third lesson that we have is that when you design a piece of software, it's a good idea to start with a business language as an abstraction layer and then dig down from there one layer after another, and that will automatically create these functions that do one thing on one layer of abstraction.
Correct, yes. So I think a topic we touched upon several times today is really stakeholder management. I mean, it sounds like a buzzword, but it is really important for project work and project management.
Yes.
And it will certainly come back in later episodes as well.
It will, for sure.
It was very nice talking to you today, Christoph.
Yes, I enjoyed it as well. And have a nice day, everyone listening, and see you next time.
See you next time. Take care, guys. So, to wrap this all up, finally, we would be happy to receive any kind of questions or comments you might have on this topic. And for now, please send it to cac@codascommunication.fm. And until the next episode, we will set up all the social media accounts for you as well. Okay, take care, everyone. Bye-bye.
Code is communication.